Now we are going to see the second method or second technique, that is binary search. This search technique or the method is the fastest searching algorithm. It is used for finding the location of an element in a linear array. Basically, it works with divide and conquer technique. Considering a real life example, take an example if you are playing some game with kids and one person asks him to keep a number between 1 to 100 in your mind and I will guess the number. In such scenario, how you are going to search or how you are going to identify or guess the right number with minimum questions? So basically, as per the previous search technique, we will first ask him whether the number is 1. He says no if he has not considered 1, or yes. If it is yes, then well okay, we have searched the element at the first position. But no, then we will ask him whether it is 2, no, whether it is 3, no. Likewise, we are going to ask till we reach a particular number which he has guessed. But now the problem is we want to ask minimum question to that kid. And what if that kid has 97 or 98 in his mind? So we have to ask him 98 questions. That's a big task and time consuming also. So the better approach is to use this binary search technique. So here what we will ask to that kid is, we will dividing that list of 1 to 100 into half. So we'll ask him whether the number is 50. He will say either yes or no. If it is yes, then good luck, the search is over, the guess is over. But no, then we'll ask next question, whether the number is greater than 50. If say yes, then we are going to search a new number which will be from the range 51 to 100. So we have lessened the data into half, that is from 1 to 50 we are going to ignore. We are not asking the questions on number 1, 2, 3, 4, 5, 6 till 50. We are directly going to start with 51 to 100. But again the same questions will be asked. Whether the number is, again we will be finding the half of it, whether the number is the same. If he says yes or no, then we will be searching in either the upper half or the previous half. This is nothing but the binary search technique. This algorithm can be applied on sorted arrays. So the element must be arranged either in ascending order if the elements are number, or dictionary order if the elements are strings. To apply this binary search on unsorted array, first we have to sort the array using some sorting techniques. And then using this binary search algorithm, we can easily search a particular number, a particular data from that array. So in this search, we are searching a particular element by comparing the middlemost element. So there are certain cases are generated. For example, case number 1. In this, if a particular element is available, the number that has to be searched is available at the middlemost element, then it's a successful search and we return the middlemost element's index number. The case 2 is that if the element being searched is found to be greater than the middle number, and keep that in mind, our list is sorted list. So if the number we are searching is greater than the middlemost, then we are going to continue the search to right sub array. Okay, so we are searching the numbers to the right sub array of that middlemost number. For example, we have seen the number the kid has selected was 97, so we will be searching from 51 to 100. Okay, that was in case 2. And case 3, if the element being searched is found to be smaller than the middlemost element, then the search is further continued into the left sub array. Okay, suppose by chance the kid has kept 25 in mind. So we will be ignoring the 51 to 100. We will be searching between 1 to 50. So all these things carries on, or these iterations keeps on repeating on sub arrays until a desired element is found or the size of the array has reduced to 0. That means it will be a unsuccessful search. Let's try to understand the same with the help of an example. Consider a same example with 7 elements, and the element to be found in this array is 15. Okay, so very first step, what we have to do? First, we have to find the middle section. Okay, so how to calculate a mid? So mid will be calculated beginning plus end divided by 2. So in this case we will be considering beginning as 0 because we want to find the middle of this. So mid is equal, the beginning is 0 and end is equal to 6. So beginning plus end divided by 2. So here the mid will be calculated 0 plus 6 divided by 2, which comes to 3. So this is your M1, that is mid one. Now we are going to compare this 15 with 20. We are comparing the element which we found at the middle with the element in question, that is nothing but the 15. We will be comparing. Now we can see that 15 is less than 20. So now what we are going to do? We are going to ignore this because no point of searching the 15 element over here because we are not going to get it. Okay, as it is less than 20. So now what do we have to do? Now we will be calculating the new end. Okay, the beginning will be same. The new end will be mid minus 1. So it will reach mid minus 1. So previous mid minus 1. So that is nothing but the 2. 3 minus 1, that is equal to 2. That is the new end because we are not interested in this end now. So this will be considered as our new end. 3 minus 1, that is 2. Now our search will be in this area only. Now again we will be calculating the new mid. So new mid will be calculated as beginning, that was 0, plus new end, that is equal to 2 by 2. So 0 plus 2 by 2, that is nothing but equal to 1. So our new mid, now our new mid, that is the mid 2, is nothing but 10. Is 10 equivalent to 15? No, it is greater. So no point in searching the 15 in this area at this location. So now again we will be calculating the new beginning now. The new beginning will be mid plus 1. Now this mid, that is 1 plus 1, that is equal to 2. So and the end will be same, that was 2. So now we will be calculating the new mid. This new mid will be 2 plus 2 by 2. That will begin, or that will come to this new mid, that is nothing but the 2. So this mid is equivalent to this mid, or the number we were searching. Yes, so that means it's a perfect match, and we will be returning 2 as the index number, and the search is successful. So some of the advantages and disadvantages are, it is suitable only for sorted data. It is very efficient if our data is very large, a big list. It is suitable for storage structures that supports direct access to the data. Some of the disadvantages are that it cannot be used on unsorted data. If at all you want to use for unsorted data, you have to sort your data first and then do the searching, binary searching. not usable for storage structures that do not support direct access to data, and it is very inefficient for smaller list or smaller data. Thank you.